Hello and welcome CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP Switch course, and this morning's video tutorial is going to be on challenge activity number 14, where we're going to be taking a look at implementing the Cisco proprietary Gateway Load Balancing Protocol, or GLBP. So here's the scenario that we've been presented with. We're going to be configuring a single GLBP group for all end devices in the network to use as their default gateway. Router 1, whenever available, is going to be the active virtual gateway, or the AVG. And this is going to be based solely off of the priority command. So that's actually going to be one of the first things we do there. Routers 1, 2, and 3 should be the virtual forwarders. Maya's already configured the new default gateways on all PCs. In any of the router or if any of the router uplinks fail, the traffic from the PC should not take a suboptimal path. So we're definitely going to be taking a look at the weighting so that we weight things out equally, or I should say proportionally, as to which links are available. And then we're going to secure the GLBP network with some MD5 hashes. So let's go ahead and dive in here. You can see we've got quite the topology. So here's router 1, here's router 2, and here's router 3. Let's first take a look at the back end here of the PC. So let's go into privilege exec and say show IP interface brief, and let's see what we're set up as. So there is the 192.168.10.101 network that we're going to be using. If I were to say show run, and I should have probably looked at default. There we go. So there is the default gateway. So in fact, I'm going to note that down here. So 192.168.10.1 is going to be our default gateway. And so that's what we're going to be setting up on the different routers here. So let's go ahead and knock this out. Let's get GLBP up and running. So on router 1, I would go from user exec into privilege exec, and then we're going to step into global config. If I real quickly here, let me take a look, and this is going to be Ethernet 00. So if I were to say do show run interface Ethernet 00, you could see that all we really have configured right now is the actual physical IP address of the routed interface. So let's jump into interface Ethernet 00, and let's kick this off. So I'm going to say GLBP, and we're going to use group number 99. That's just a number that I like to use for the FHRP group number. So GLBP 99 IP, and we are going to be the default gateway here. So 192.168.10.1, because that's that default gateway address. Remember, the active virtual forwarder is going to be this router. So we want to make sure that we have the priority relatively high. So I'm going to set the priority to 200, a value I like to use for the active virtual gateway, or the virtual master router, or the active router, depending on if it's VRRP or HSRP respectively. And then last but not least, we're going to go ahead and say GLBP 99 preempt. And do we want to have a delay? We could certainly work a delay in here. And what would that look like? Number of seconds. So we'll say 270. So when I say do show run interface Ethernet 00, you can see that we've got our GLBP settings. So here are the rest of the settings that we could have turned on. Okay, so we'll come back to those, because you can see the authentication command is definitely one we're going to want to have spun up. So if I were to say do show GLBP, you can see that this is what we have right now. And so let's kind of walk through some of the different output fields here. So you can see that it's group 99. You can see that the state is active. And obviously we've only had a single state change, which was literally this router coming online as the active virtual forwarder. So here is my virtual IP address. As you can see, we have the default values here. The hold time, or I'm sorry, the hello time is 3 seconds. Hold time is 10 seconds. And then we can see when the next hello is going to be sent. The redirect time and the forwarder timeout, remember, those are related to if we were to have a failure of one of the active virtual forwarders, how soon would we stop using and then flush out that active virtual forwarder MAC address. Preemption is enabled. My minimum delay here is 270 seconds. Who is the active? Well, it's the local router. It's this router right here, router 1. Our standby is unknown. And the reason it's unknown is because we haven't configured anything yet, any of the standbys. The priority is 200, and we configured that. The waiting. So here's the waiting. You can see the waiting is 100. The default is 100. We're actually going to be manipulating this here a little later on. And then there are the thresholds, the lower and the upper. And we'll talk about this as we set these. And so these thresholds that you look at, if we drop below the lower threshold, that means that we are going to relinquish our active virtual forwarder status, not the active virtual gateway status. So, and that's a key thing to keep in mind, is that the AVG status is independent of the AVF status. In other words, I can be the active virtual gateway, right, and have lost my status as an active virtual forwarder. And we'll talk about that when we look at the topology. And then the upper is if we are above that, we regain our status. So what is our load balancing mechanism here? Well, it's round robin. So who are the group members? Well, you can see the local router, and that's my local IP address, the physical IP on my physical router interface. And so there is one forwarder. And since I came up first, right, we configured the AVG, and by default, if all I did was enable GLBP, I'm going to come up as the active AVG, right? I'm going to come up as the active virtual gateway, and I'm immediately going to be active virtual forwarder 1. So you can see that my state as AVF1 is active. We have that simple single state change when we came up. And then here is our MAC address, right? 0007 Baker 400 6301. And again, that is the GLBP group number, because that is the hexadecimal value that is equivalent to the decimal value of 99. So the owner ID, that is me, right? The local switch. Redirection is enabled. Preemption is enabled. And with the active virtual forwarder, the delay is 30 seconds. Now remember, from this point down, let me draw a line here. From this point down, we're talking about the active virtual forwarder, not the active virtual gateway. And again, remember that the active virtual gateway status is not dictated in the same fashion that the active virtual forwarder status is. And again, here AVF, you can see active is local, and the waiting is 100. And so we've got one of our nodes up. Let's go ahead and let's bring up the other nodes. So if I were to come back over to our diagram here, let's come to router 2. And let's do the same thing for router 2. We're going to go from user exec into privilege exec, and then drop into global config. Let's say do show run interface Ethernet 00. And again, you can see we just have our IP address. Let's jump into interface Ethernet 00. We're going to say GLBP 99. IP is 192.168.10.1. And again, that is the virtual IP address that we're going to be using for GLBP. We're going to say GLBP 99 priority 150. We're going to say GLBP 99 preempt. And again, the priority is still below the router 1 active virtual gateway priority. And so again, that's one way to think of it, right? Is the priority setting is related to the active virtual gateway status, not to the active virtual forwarder status. And so you can see we've gone from listen to active, and we're going to be standby here shortly. So, and that's pretty much it. So do show run interface Ethernet 00, and that's what we have right now. We've got our virtual IP configured. We've got our priority configured to be lower than the the active AVG, or the active virtual gateway, and then we have our preempt statement in there. So let's go ahead and say do show GLBP, and let's see what we've got here. So remember, this is the standby node, as evidenced here. State is standby, and right up until here, this is our AVG, and then here are the forwarders that are seen, and this is AVF1 information, and you can see forwarder 2 and forwarder 1. This is our AVF2. So the state is listen for forwarder 1, because remember, who is the owner of forwarder 1? Remember, the owner of forwarder 1 is router 1. And so it says right there, active is 192.168.10.11. They are the primary. But my state as router 2 is I am listening, right? So router 2 is actively listening to see, do I need to pick up for AVF1? So remember, we're on router 2 here. So for forwarder 2, and this is the second one to come up, my state is active. This is my MAC address, right? This is the virtual MAC address that the active virtual gateway will respond to ARP queries for the default gateway. This is the active virtual forwarder virtual MAC address for router 2. You can see here we've got, there is our group number, because 63 is 99, and that is our AVG number. I'm sorry, our AVF number. That is the active virtual forwarder number. You can see up here it's 01 and then 63. Owner ID, that is router 2's MAC. And so again, now we've got a little bit more information here. And this would be the opposite over on router 1, where it would say for forwarder 1, it is active and it is listening for forwarder 2, because if for whatever reason forwarder 2 goes away, and we're going to see this happen when we start to tweak our weighting values, if AVF2, if we were on router 1 and AVF2 were to go away, router 1, the AVG, who is in control of AVF1, is going to take over, right? Okay. And let's take a look at, so it learned, this is router 2, he learned about the active virtual forwarder MAC address from router 1. He learned it. However, when we configured router 2 as an AVF, he defaulted, and this, again, this is the default MAC address value that's going to be passed along here. All right, let's go ahead and clear the screen here and move on to bring router 3 into the fold. So let's go ahead and take care of router 3 here. So we'll go from user exec to privilege exec into global config. Let's say do show run interface Ethernet 00. And let's go into interface Ethernet 00, GLBP 99 IP 192.168.10.1, GLBP 99, let's say priority of 1, and we'll set this guy to 125, still making him one of the standby routers, and the priority well below of the active virtual gateway priority of 200. And there you can see we've gone from listen to active. And then finally, GLBP 99, GLBP 99 preempt. So do show run interface Ethernet 00, and there we go. So not much different from router 2, with the only exception being that the priority is about 25 lower, but that's okay. So let's say in, and let's give it a write, or not a write mem, but a show GLBP. And we can take a look at the brief output here, right? So show GLBP brief is going to give us some information as well. And again, it's just sort of a consolidated format. So here we are, we have our group number. Forwarders, right? You can see we've got the 3 forwarders. So this is AVF1, we know that's router 1. AVF2, we know is router 2. And AVF3, we know is router 3. Remember, you can have a maximum of 4 AVFs in an active virtual gateway group. So what is the priority here? Well, my priority is 125. But remember, this first line that you see here, and I'm going to attempt to do a nice thin line along the bottom here. So that first line right there, that line is your active virtual gateway status. These are your active virtual forwarders down here. And so our priority is 125 for the active virtual gateway status, and we are listening, right, because we may have to step in and take over. There is the active virtual gateway address. There's the active virtual gateway router. .11, we know that that is router 1. Who is the standby? Well, the standby is router 2, and router 2 is the standby because his priority was 150. My priority, and when I say my, I mean router 3, router 3's priority was 125. Now we've got these active virtual forwarders here. So just like when we saw on router 2, take a look. Router 3 says, yep, I'm listening for router 1 and router 2's AVF. Here are their virtual MACs, and I'm listening for those because there's a possibility I may need to take over. But for AVF 3, router 3 is the active. Here is the virtual MAC, again, 63 being 99 in decimal. The hexadecimal 63 being 99 in decimal. And then AVF 3. And who is the active router for that? It is me, the local router. And so the brief output sort of consolidates it and really pulls out, we don't see all the timer information in here or the waiting or the standby and the preempt. So if you're just looking for a quick, dirty sort of like, what is the status? What is everybody seeing right now? Show GLBP brief is a great way to see that information. But again, this allows us to see what's going on in a sort of a consolidated fashion. All right. So now one of the requirements was that we secure everything. So let's go ahead and take care of that right now, because that's kind of low-hanging fruit with respect to what we're talking about. So do show run interface Ethernet 00. So you can see this is the setup that I've got right now. So we're going to say GLBP 99 authentication. Now I can do text, which is plain text, or we can say MD5. Now I could refer to a key chain. However, we didn't create a key chain. We just did a key string, or we're going to do a key string. And so then I'll put my key string in as just ABC 123. Now, this is going to break GLBP with the other peers, because obviously we haven't set up authentication yet. So let's kind of roll our way backwards here. You can see that router 2 is also reporting that there's an issue. So let's make sure we're in Ethernet 00, do show run interface Ethernet 00, and we're going to say GLBP 99 authentication MD5 key string ABC 123. And then we'll do the same thing over here on router 1. Let's get router 1 back up. Go from user exec to privilege exec into global config, interface Ethernet 00. And you can see router 1 is seeing bad information from both router 2 and router 3. So we'll fix that. We'll say GLBP 99 authentication key string, MD5 key string. Some problems typing here. Key string ABC 123. All right, so it'll no longer be bad authentication. At this point, we should be good to go. So let's see. Do show GLBP brief. All right, so what does the status look like here? Well, we see right away that the active virtual gateway status, and let me see if I can get this in here without ruining the output. There we go. So remember, this is the active virtual gateway status. This is the active virtual forwarder status. So for the active virtual gateway for group 99, our priority is 200, and we are active, right? So here is the virtual IP address again. Who is the active virtual gateway? We are the local router, so the router that we are issuing this command from. Who is the standby router? You can see that the standby router has transitioned now to router 3, and we'll see if this changes as we go on. Then we've got the active virtual forwarder. So for 1, 2, and 3, you can see for 1 we are active, but then we are listening to router 2 and router 3's active virtual forwarders, who are using these MAC addresses right here, because if for whatever reason router 2 or 3 were to crash or go down, or as we're going to do here in a second, the weighting were to change in some form or fashion, we would want to make sure that we take over. So that's why we're listening, right? If they go away, we're going to step in there and take over. And then we've got the active router. So again, router 2 and router 3, respectively, for AVF2 and AVF3. All right, so let's clear the screen there. All right, so now we're going to get into the weighting, and let me go back and take a look at the scenario here to see what they are requesting. So configure a single GLBP group. So we've got that knocked out. R1 should be the active virtual gateway. We've got that. We set the priority to 200. We're using GLBP group 99. 1, 2, and 3 should be virtual forwarders, and they are. We've seen that. She's already configured the new gateway. We know what that is, 192.168.10.1. If any of the router uplinks fail, the traffic from the PCs should not take a suboptimal path. And that's kind of cluing us in to the weighting. And secure the peers. You can find the gateway information for the PCs and the job aids. Okay, so if we needed to test connectivity, and let's do that right now from some of the PCs here. So when you need to test your GLBP configuration, ping the server IP 192.168.0.44 from any of the end devices. So let's make sure, let's see where we stand right now. So from PC 1, if I were to click in here and go into privilege exec and say ping 192.168.168.0.44, how do things look? I have to ARP out, so we're good there. And let's check PC 2, can we ping out? We'll go into privilege exec ping 192.168.0.44. We'll have to ARP out, I'm sure. Yep, there we go. Nope. All right, so we're good there. PC 3, from user exec to privilege exec, and we're going to say ping 192.168.0.44. So how do things look? And PC 3... interesting, PC3 does not like that. So let's take a quick peek on PC3 here. All right, so let's see what PC3 has going on. Let's pull this command back and let's say show run include gateway. Oops. All right, so the IP default gateway, so can we ping our gateway? Ping 192.168.10.1. Can I even ping my default gateway here? All right, Control-Shift-6 or Control-C. There we go. Let's say show IP interface brief here. So might have some issues. 192.168.100.103 and gateway 10.1. That's interesting. So the IP is 192.168.100.103. Show, let's see here, show IP interface brief. And these are 10.102. Aha. So do you see the issue here? Let's go back over to PC1 and do show IP interface brief, or show IP interface brief. 10.101, 10.102, and then PC3 is 100.103. So what do you think the problem is? Yeah, there's an IP address mistake here. So let's get an interface Ethernet 00, and let's say IP address 192.168.10.103. Oops, sorry. Let's get that 255.255.0, assuming it's a /24 there. and let's say end write mem, and now let's run those ping commands. 68.10.1. Can I get to my default gateway? All right, so there we go. So it looks like just in IOU that the IP address was wrong. Now let's see, can we ping out to 192.168.0.44? Okay, now we're on track with PC3. All right, a little unexpected troubleshooting required there. All right, so we take a look at the diagram. So we want to set up waiting. Now remember, the waiting that we're talking about here is for the active virtual forwarder. This waiting is not going to impact the active virtual gateway status. Remember that the active virtual gateway status is predicated on, and I didn't want that to switch on me there. The active virtual gateway status is predicated on whether router 1 and router 2 and router 1 and 3 and 2 and 3. In other words, the active virtual gateway status is predicated on whether or not they can communicate with each other. So if that link goes down, right, router 1 is still going to be the active virtual gateway because he can respond. Because again, what's the purpose or the role and responsibility of the active virtual gateway? It's to respond with the virtual MAC addresses for the active virtual forwarders. So even if that link goes away, router 1 can still respond to ARP replies that are coming in from PCs 1, 2, and 3 because he's going out that interface. Again, remember, we're talking about this upstream interface here. So to be the active virtual gateway and to serve in that capacity, router 1 does not need to be able to access, router 0. It doesn't need to be able to access router 0. He needs to be able to communicate with routers 2 and 3. And that's what we're seeing here. So when we're talking about the active virtual forwarders, that's when we're talking about the waiting. So let's go ahead and get into that, and we'll have a discussion about the lower and the upper, which will come into play here in just a second. So if I'm on router 1 and I'm in interface Ethernet 00, which is where I should be, and let's say do show run interface Ethernet 00. All right, so we've got our authentication set up. We've got our preempt delay, our priority, and our GLBP IP. So now we need to track an interface, and that was 01 on all of these, right? Yeah, so they're all Ethernet 01 is their upstream facing interface. So if I were to say, let's track it first. So, whoops, and actually we don't want to be in the interface mode. All right, so if I was to say track, and it can be 1 to 1,000, I'll simply use track 99, and I'm going to track an interface. Remember that GLBP, just like FHRP, requires objects to track. HSRP has that built-in interface tracking built into HSRP. However, here we're going to have to use an object. So track 99 interface Ethernet 01, and then what do we want to track? An IP or the line protocol? Well, we want to know if it goes up or down, because if it goes up or down, that's what's going to dictate how we change or manipulate the weighting that gets set. All right, so track 99 interfacing the one line protocol, and that is it. So there's my track object. Now, you can see I'm in this config track here. Well, we don't need to do anything else. So I can simply exit from there. Now we want to go into interface Ethernet 00, into our GLBP group interface, which is Ethernet 00. And now we're going to say GLBP 99. And so by default, the weighting is 100. So we'll go ahead and we'll leave it at 100. So GLBP 99, weighting 100. And here's where we put in the lower value and the upper value. So let me first start with the lower value. Now, the lower value is a value that if we drop below the lower value, then we are going to forfeit or we're going to voluntarily give up our active virtual forwarder status. So router 1 is active virtual forwarder 1. If it drops below 80, right, then he is going to forfeit or give up his status as active virtual forwarder 1, which means that MAC address and the router that will be responding to queries to that MAC address for AVF1, router 1, will become another router. And then we have our upper limit, and we'll say 90. The upper limit of 90 is going to mean that once we go above 90 in terms of the weighting, then we are going to take back, after the preempt delay of 30 seconds, we're going to take back our status as being responsible for the active virtual forwarder. Now, the last thing that we need to do is we need to say GLBP 99 weighting, tracked object is 99, and so what are we going to decrement the weighting by when the interface Ethernet 01 fails? Well, we want to make sure that we get below the lower, but when we come back up, we want to go higher than the upper. So if I'm saying that the weighting is 100, the minimum value that I could use, sorry about that, let's get back to router 1. The minimum value that I could use would be 21. I would have to decrement by at least 21 to drop below 80. If I did it by 21, that would take me to 79. And that would be enough. The upper, again, when the interface Ethernet 01 comes back up, we are going to increment the weighting by whatever the decrement value was. So again, if I say decrement 21, it drops to 79. Router 1 will no longer be the AVF responsible for AVF1. It would become another router. And then when the interface came back up, he would preempt after the default of 30 seconds. And we would add back in whatever was subtracted out as the decrement value back to the current decremented value, bringing us back up to 100. And the key point here is the 100 is above the upper value. So theoretically, we could say the upper value was 99 even. Because again, when it comes back up, and we're only talking about tracking a single interface, I thought the book did an amazing job when it showed, and this is probably not going to do justice to the drawing in the book, but it showed, and this was distribution 1, distribution 2, and it had the routers here. But then there were 2 routers here, and each router had multiple connections out like this. And so what would happen for router 1 and router 2 is that interface, we would track this interface right here. And if it went down, and let's say that we had the lower set to 80, if that interface went down, we would only drop it by 15. Which means it would be at 85, so then we wouldn't give up our status, because again, we still have that link right there, right? And same thing here, we'd be tracking both interfaces on this guy as well. Now, if that interface also went down, so that one goes down and this one goes down, we would be tracking that, and we could say decrement by 15 for this track object. Now, that's a total of 15 plus 15 is 30. That takes us to 70, and we are less than the lower boundary now, because again, and it makes sense, right? Logically, I no longer, as router 1, I have no upstream paths available to me. They're both down. So do I want any traffic from, and if we had access layer switches here doing their thing, right? Do I want any traffic coming this way for AVF1, AVF1, which would be router 1, when he has no upstream paths? He can't go anywhere. So the answer is obviously no. So we would want to give up that active virtual forwarder 1 status. And sorry about active virtual forwarder 1 status. We would want that to transition here to router 2, who still has 2 legitimate uplinks, right? And that is really all the boundaries are, what the boundaries are used for. Now with a single link, right, we have one variable that we need to deal with. So as soon as the first interface goes down, we want it to dump below that lower value. Because if router 1 only had a single interface upstream, facing upstream, and that interface goes down, that's it, he's done. He has no capability of sending traffic forward. So we want to drop and decrement whatever the weighting is below our lower value. And I'm going to use, I'll use different values on each of the 3 routers to demonstrate how we would set this up. That you don't have to use the values that you see here. So again, single interface out, when we dump it down, we better dump it below that lower value, because if we don't, then he's going to continue to serve in the capacity as active virtual forwarder 1. And we don't want that. And again, the upper value can simply be 1 less than whatever the weighting value is, because that's going to be the value that we're going to need to get above in order to take back our status as the active virtual forwarder. Okay, so hopefully that makes sense. We've got 2 more of these to do, and those should sort of solidify what we're looking at. So we're going to say waiting track 99 decrement, and again, I'm going to say 21, because that would take it down to 79, and that is enough to get below the lower boundary of 80, and we've got a single uplink, and at that point all we're saying is, hey, that uplink goes down, it's game over for router 1 for the active virtual forwarder, not the active virtual gateway. Remember that. Even when that Ethernet 01 link goes down, the active virtual forwarder 1 will transition to one of the other routers, router 2 or router 3. But the active virtual gateway status, and we will see this, will stay with router 1, because router 1 can still successfully communicate between router 1, router 2, and router 3. And his priority is 200. All right, so that takes care of router 1. Let's go ahead and jump onto router 2 and set up some tracking here. All right, so router 2, and we'll do this a little more rapidly here. So let's go from privilege exec to global config. We're going to say track 99 interface Ethernet 01 line protocol. So again, we're just tracking the line protocol, and then interface Ethernet 00. This is where we're going to put our GLBP statements, right? GLBP 99. Now waiting. So here's what I'm going to do. I'm going to say waiting 200, and look at the values that you can use from 1 to 254. So I'm going to say waiting 200, right? So the lower, I'm going to make it, and let's say, I don't know, 150, right? So if we had a single interface right here, you can tell me right here what the decrement is going to have to be when we have a single upstream interface, and we want to make sure that if that interface, Ethernet 01, goes down, that the active virtual forwarder AVF status of router 2, we want to ensure it gets transitioned to one of the other routers who is still up operational and has an upstream facing path. So we know right now that it's going to be 51, because that would dump it down to 149. So we say lower 150, the upper, I'm going to make 199, because as soon as that interface comes back up, we're going to increase the weighting to 200 from what we decremented it by, which was 51, putting us above that 199. And actually, I'm going to have to say upper 199. All right, so then we're going to say GLBP 99 waiting track 99, and decrement is what for this one? Exactly, the decrement's going to be 51. So do show run interface Ethernet 00, and that is what it looks like right now. So let's go ahead and say end write mem, and let's do that on router 1 just to make sure. End, END, write mem. All right, now over to router 3. And this is going to wrap things up here for us. So let's go into privilege exec, global config, do show run interface Ethernet 00. All right, so there's our setup. So let's go ahead and say track 99 interface Ethernet 01 line protocol interface Ethernet 00, and we're going to say GLBP 99 excuse me, weighting. And again, look what we can do with the weighting. It can be anything from 1 to 254. So what if I were to make this one 150? So the lower could be 125, and let's make the upper 145. So again, it's going to be dependent on the decrement value, but right here you can tell me if this was a single interface. If this router had a single interface facing upstream and that interface went down, and we wanted to ensure that he transitioned his AVF status and AVF responsibilities to another router, what would we have to decrement this by? Exactly, 26, at least 26, so 26 or more. So GLBP 99 weighting 150, lower 125, upper 145. GLBP 99 weighting track 1, or I should say track 99, and then our decrement value, which is going to be, and we'll make it a funky value, so 28. Because again, if it's 26 or greater, that's going to achieve what we're after. So we'll say decrement 28. All right, and so we'll say write mem there. All right, so now let's see, look at router 1, show GLBP, and let's see what we've got here. Specifically, we're interested in these active virtual forwarders because, oops, sorry about that, router 1, there we go. So here we go. So there are 3 forwarders, and there is a single forwarder active on this router. So let's line these out here. Let's see if I get, so there's forwarder 1, forwarder 2, forwarder 3, right? So this is AVF1, AVF2, and AVF3. So when we take a look here, you can see active is the local, and what do we have over here? And the weighting is 100. Because remember, when we were working with AVF1, we went ahead and just stuck with the default value. Take a look down here. What is the weighting here? The weighting is 200. Remember, we configured it to 200. We configured this one here to 150. So we've got 3 different weightings, but everything is working as it should. Because who is the owner ID right now for AVF2? Well, it's router 2. Who is the owner for AVF3? It's router 3. So again, you can see that the weighting values that we entered, right, can be different. And you can see there's the IP for router 2 and the IP for router 3 here, and the IP for router 2 here. And there's the preemption is enabled. The minimum delay is 30 seconds. Okay? All right. So let's go ahead now and let's test this out, because I think we've got everything we need with respect to the requirements for the lab, or for the answers anyway. But now let's test this out. Let's see what happens. So if I go into global config here, and actually we can do it from the other side. So if I get onto router 0, and router 0 is Ethernet 01, 02, and 03, router 1, router 2, router 3. So this will be interesting. So on router 1, let's go ahead and say debug GLBP, and I want to see events, and I want to see errors. All right, we're going to do this on router 1. So over here on router 0, I'm going to go from user exec to privilege exec into global config interface Ethernet 01. So do show run interface Ethernet 01. So from this side, right, so from the upstream facing side, we're going to shut down Ethernet 01 right there, and that's going to kill this link here. And let's see what happens on router 1. Does router 1 respond with anything? So now let's say show IP interface brief. Whoops, sorry, show IP interface brief. So we can see it still shows up, But there we go. The neighbor relationship went down, so obviously the interface is down, should be down, although it's still showing up here. Did I shut the right interface down? Do show IP interface brief. Yeah, so we shut that down, so it should not be showing on router 1 up. And maybe this is... All right, so we'll do it from router 1 side then. It looks like it's not going to cooperate here. So interface Ethernet 01, and let's go ahead and say shut. So now we're physically shutting down the interface. So what we should see here from a GLBP perspective is we've shut the upstream interface down, right? And unfortunately, we're not seeing any of the debug information. So let's say show GLBP. We may be waiting for the preemption delay to take over here. So we'll give it about 30 seconds. And then hopefully we're going to end up seeing something. So see how it still shows is active right now. So the interface went down. We were tracking the interface. And it still shows active. So we may be in that 30-second waiting period here. And still showing active. And let's say show GLBP. And for AVF1, the waiting is 100, but it did not drop. So let me make sure I'm not being show interface Ethernet 00. I'm sorry, 01. Let's make sure that is down. So it is down. Show run interface Ethernet 00. So we've got everything in there. We've got our decrement statement in there. We should drop below the lower. And let's make sure, show GLBP brief. So we are still showing as active here. And I'm hoping that this isn't a 270-second wait, because that should not be for the AVF. Let's do this. Let's come over to router 3. And let's say show IP interface brief. So router 2 is going to be really busy here in a second. We're going to global config interface Ethernet 01. I'm sorry, yeah, Ethernet interface 01. And we'll say shut. So EIGRP is going to go down. The interface goes down. Do show GLBP brief. And so we're active. So let's see. Let's see if we've got like a 30-second, so the preempt should be 30 seconds, and let's see what happens here. Because what you should see happen right here is we're on router 3. That active status should go away. It should go into the listen state. And do show GLBP. Whoops. Do show GLBP. So we've got the track object in there. State is up. Decrement is 28. You can see the weighting and the thresholds here. You can see the weighting and the thresholds for the AVF. So how is it seen? Did I not track the right interface? Do show run interface Ethernet 00. Or do show run include track. Oh, so do you see the mistake right there? So I'm actually tracking the wrong interface. Let's see, is this show run? Did I do this? Show run include track. Okay, so router 2 was done right. Let me guess. The two routers that I went to, show run include. Whoops. Show run include track. Oh my goodness. So the two routers I go to do the demo on are the ones that I've got the mistake here. So again, tracking the wrong interface, that is going to be a problem. So we're going to say no track 99 interface, or actually let's just add in, see if we can do this. Track 99 interface Ethernet 01 decrement interface, I'm sorry. track 99 interface Ethernet line protocol. Sorry, Ethernet 01 line protocol. And there we go. All right. So fortuitous failure. Basically had the wrong statement on there. And then I moved to router 3 thinking, yeah, it's got to be right there. So then it's wrong there. The only place it was right was on router 2. So, but it gave us the opportunity to do some troubleshooting. So here is what we're looking for. Now we're seeing the tracked object, the state went from up to down. So now I can continue on here, show GLBP brief. So, excuse me. All right, so we went from active to listen right there. That was our 30 seconds. And so if I do show GLBP brief again, this is a great set of output here. And let's get back to router 1. Great set of output here, because take a look at what we see. So remember that first line, we're talking about the active virtual gateway. So who is the AVG? The AVG is router 1. So even though router 1 has lost its only upstream facing interface and cannot forward traffic upstream to router 0, he has not lost his connectivity to router 2 or router 3. Therefore, that is not going to impact his ability to serve in the role as the active virtual gateway, because again, the roles and responsibilities of the active virtual gateway are to do nothing but to reply to ARP requests for the default gateway and to, in a round-robin fashion, give those virtual MAC addresses out to the routers as well as to respond to the clients, right? So again, here are the values, but look at the state right now, because we have forfeited by virtue of the fact that we decremented, I think it was right above here, we decremented by 21, I think it was. So we are giving up our role as an active virtual forwarder. Let's take a look at a little bit more verbose output here. If I were to say show GLBP, and let's see what it says right now. So here it is, track object 99, state down, right? So we're still doing round robin, but we have removed ourselves from the active virtual forwarder status. So for forwarder 1, right? Who is the owner ID for forwarder 1 now? So who picked up the slack for router 1? Who picked up the slack for router 1 when router 1 went away? Well, here's our owner ID. So if we look down here, we see that that is still router 1, right? But we are no longer active. So who is the active router? Router 3 has taken over for router 1 with respect to the active virtual forwarder, not the active virtual gateway, right? So then router 2 is still the active virtual forwarder for forwarder 2. And forwarder 3, if we were to go down a little bit further here, you would see it's router 3. So right now, router 3 is responsible for the virtual MAC address 6301, and he's responsible for the virtual MAC address, and let's go ahead and get that up here, and he's responsible for the active virtual MAC address 6303, which was his. He learned it from router 1, because router 1 is the active virtual gateway, but he is still the active virtual forwarder for that MAC address. So he's basically doing the work of 2 active virtual forwarders. So let's see what that looks like from router 3's perspective. If we were to say do show GLBP brief, you can see that he shows as local. He is the active virtual forwarder for these 2 virtual MAC addresses, right? 6301, 6303. All right. So now let's do this. Let's make router 2 really busy. So remember, what am I doing? I'm tracking the wrong interface over here. So do show run and include track. You can see I tracked the wrong interface. So let's sort that out. Let's exit out, and we're going to say track 99 interface Ethernet 01, line protocol. Now, it should immediately pick up that is down. So you can see that it goes from an up to a down status because the tracking picked it up that interface is down. And now what's going to happen is it's going to decrement in that 30-second window. It's going to decrement the weighting that it has set right now. And we're going to see a change. And so if I were to say show GLBP brief, you can see I'm still the active for both of those, but there you go. The 30 seconds is up. And for forwarder 1, I go to listen. For forwarder 3, I go to listen. So what does that look like now? So take a look. Router 1 and router 3 are basically doing nothing, but who is still in the game? Well, router 2, let's come back to router 3 here. Router 2 is still in the game, and now router 2 is very, very busy because he is the active virtual forwarder for all 3 virtual MAC addresses, and I can tell because of the 121212. Excuse me. But again, did that in any form or fashion impact the active virtual gateway? No, because router 1 is still the active router and the active virtual gateway, because router 1 can communicate with routers 2 and 3 without any issues. However, the active virtual forwarder status, router 2 is the only guy who has a uplink to router 0. And so he will be the only router right now responding to ARPs, to those virtual MAC addresses that are being handed out in a round-robin fashion. All right. Well, this has sort of been a tour de force here of GLBP. We looked at the authentication. We looked at tracking the interfaces. We looked at the basic setup. I really hope you have a good grasp of the whole waiting process. Again, this scenario, I would have liked to have seen the scenario that we had out of the book, where routers 1 and 2 had multiple uplinks to router 0, because that gives us a little bit more of a challenge and more flexibility to say we're going to decrement if interface A goes down, we're going to decrement by 20, but that still doesn't go below the lower boundary. And then if interface B goes down and that router loses all upstream facing interfaces, we drop it by another 20 and take it below the lower value in order to force it to give up its status as an active virtual forwarder. All right. So this is going to wrap up challenge activity number 14, where we took a look at GLBP. Next, we're going to be looking at HSRP v6. All right, guys, have a great day, and I will see you tomorrow night.